What we really wanted to achieve here is like, well, why make this really fast car that's crazy fast and everything? We got to show that an electric car is the best car.
The future was supposed to belong to electricity, and the world Tesla once imagined seemed almost inevitable. Elon Musk's dream of a planet where everyone drove only electric cars once looked like a future that could not be reversed.
We have a very good relationship with Toyota, and they're a significant shareholder in Tesla.
While the whole world jumped on the electric vehicle hype train, Toyota seemed strangely slow. But as it turns out, they were quietly preparing a card that could change the entire game. It was not a battery, and it was not a super fast charger either. The thing they were betting on was the internal combustion engine, a technology many people in the industry thought had already been left behind. But this is not just Toyota recycling an old engine. What Toyota is developing is a completely new generation of engines, much smaller, much cleaner, more powerful, and capable of running on eco-friendly fuels like synthetic biofuels or hydrogen. While many automakers are struggling with rising battery prices, a shortage of charging stations, and overloaded power grids, Toyota has quietly chosen a different path, one that is calm but extremely calculated. If this strategy works, it could seriously shake the almost exclusive position electric vehicles currently hold. So what exactly is Toyota holding in its hands, and could this really be the key to changing the future? In today's video, we're going to follow the traces of this quiet revolution and find out whether this path could truly be the answer to a greener future. Before we get started, do not forget to hit the like button and subscribe to the channel. Elon Musk once believed he had pretty much already won. Tesla's stock price was soaring, and traditional automakers were scrambling to catch up. At that moment, the future seemed to belong entirely to electric cars. But while the whole world was caught up in that revolution, the Japanese auto giant Toyota was quietly developing a technology that could flip the entire situation upside down. This is not just a regular hybrid upgrade. Even Elon Musk has admitted that this kind of technology has the power to force the entire electric vehicle industry to redefine the future. But before we dig deep into that story, we need to understand the road that brought the auto industry to this point. Everything began almost a century ago, inside a small textile factory in Japan. The brilliant inventor Sakichi Toyoda created an automatic loom, completely transforming the textile industry and introducing the concept of jidoka to the world. The core idea was to let machines detect problems on their own and stop automatically, making sure quality was protected from the very beginning. This philosophy would later become deeply rooted in Toyota's production culture. Carrying on his father's vision, Kiichiro Toyota turned his attention to the automobile industry. He recognized the limits of American-style mass production and developed the just-in-time method, meaning producing only what is needed, exactly when it is needed, and in the exact amount required. When jidoka was combined with just-in-time, the Toyota Production System, or TPS, was born. This was a major innovation that reduced waste and maximized quality. On top of that, the philosophy of Kaizen, meaning continuous improvement, became the core driving force behind Toyota. From regular employees to top executives, everyone was encouraged to come up with ideas to make things a little better every single day. This culture helped Toyota maintain its leading position in the industry for decades. When the oil crisis broke out in 1973 and fuel prices shot up, Toyota was already ready to meet market demand with the fuel-efficient Corolla. Meanwhile, American automakers struggled because of their large, gas-hungry vehicles. Then, in the early 2000s, Toyota once again moved ahead of its time by launching the Prius, the world's first mass-produced hybrid car. The Prius combined a gasoline engine with an electric motor to maximize efficiency and reduce emissions. It opened the era of sustainable transportation and redrew the future of the auto industry. From a small weaving factory, Toyota grew into a global automotive empire thanks to its optimized production philosophy and long-term vision. And now, at a time when all eyes are focused on the electric vehicle race, Toyota may once again be holding a card powerful enough to shake the whole board. The internal combustion engine has played a central role in technological progress for more than a century. It has powered countless vehicles that help build modern society, while its efficiency, power, and durability have constantly improved. This journey goes back to the late 18th century and the early 19th century. In 1791, John Barber patented the gas turbine. In 1794, Thomas Mead received a patent for a gas engine. That same year, Robert Street built the first engine that used liquid fuel. These early experiments became the foundation for the breakthroughs that followed. By 1807, two French engineers, Nicephore Niepce and Claude Niepce, created a prototype internal combustion engine called the Paray-Lafoure, and it actually managed to power a boat on the Saône River in France. Later, Swiss engineer François-Isaac de Rivaz built an internal combustion engine that used hydrogen as fuel and installed it on a primitive vehicle. This is considered one of the earliest examples of using an internal combustion engine in an automobile. Then, in 1876, German engineer Nikolaus Otto, together with Gottlieb Daimler and Wilhelm Maybach, developed the compressed four-stroke engine. This design, commonly known as the Otto cycle, became the foundation of the modern internal combustion engine. With 4 stages intake, compression, combustion, and exhaust fuel could be burned more efficiently, producing greater power. Toyota's history with internal combustion engines has always been tied to innovation and an obsession with quality. Toyota engines have earned a worldwide reputation for outstanding durability and performance. One great example is the 2JZ engine that appeared in the early 1990s. This was an inline 6-cylinder 3.0-liter engine used in models like the Toyota Supra, and it quickly became legendary among car enthusiasts. The 2JZ was built so strongly that it could handle high-pressure turbo setups, making it a top choice for racers and tuners. From a technical standpoint, Toyota was always one step ahead. In 1995, the company introduced the VVT-I variable valve timing system, marking a major leap forward in engine performance and fuel efficiency. This system optimized the timing of the intake and exhaust valves, increasing power while reducing fuel consumption. Building on that foundation, Toyota developed dual VVT-I, which allowed both the intake camshaft and exhaust camshaft to be controlled at the same time, making engine performance far more precise. By 2007, Toyota introduced the Valvematic system. This technology could continuously adjust valve lift and valve timing, allowing the valves themselves to control the air-fuel mixture instead of relying on a traditional throttle body. As a result, fuel efficiency improved, emissions dropped noticeably, and engine response became much quicker. As environmental pressure grew and the entire auto industry faced the challenge of reducing emissions and improving fuel economy, Toyota responded with lean burn engines. This method burns a mixture with a higher air-to-fuel ratio than a normal engine. Toyota had already mass-produced this type of engine back in 1984, becoming the first company in the world to do so. Thanks to this technology, fuel economy improved significantly, emissions were reduced, and Toyota contributed to environmental protection. Then, in 1997, Toyota shook the industry once again by launching the Prius, the world's first mass-produced hybrid vehicle. The hybrid Synergy drive system combined a gasoline engine with an electric motor, allowing the car to use each power source separately or both at the same time, depending on driving needs. The result was impressive fuel economy and low emissions. That was the moment a new standard for eco-friendly vehicles was established. Toyota's belief in the internal combustion engine has never really wavered. The company continued developing smaller and more efficient engines that could use many different types of fuel, including gasoline, synthetic fuel, biodiesel, and even hydrogen. More importantly, these engines were designed to meet increasingly strict environmental regulations while being widely applicable to hybrid vehicles and biofuel-powered vehicles. In 2008, while Toyota was still refining its hybrid technology, a new challenger appeared in the market, Tesla Motors, led by Elon Musk. His vision was extremely clear. Electric cars were the future. Tesla's journey was built on innovation and burning ambition, quickly challenging traditional automotive giants and rewriting the rules of the industry. In reality, Tesla Motors was founded in 2003 by two engineers, Martin Eberhard and Mark Tarpenning. Their goal was simple but bold: to create a high-performance electric sports car. In 2004, Elon Musk led the first investment round, invested $6.5 million, and became chairman of the company. From there, he became deeply involved in product design and development strategy. He pushed Tesla toward bold goals and shaped the direction of the company. Then, In 2008, Tesla finally brought its first masterpiece to the world, the Roadster. This sports car could reach 60 miles per hour in under 4 seconds and drive more than 200 miles on a single charge. The Roadster completely shattered the stereotype that electric cars were slow and boring. Building on the success of the Roadster, Tesla launched the Model S sedan in 2012. Thanks to its excellent performance, top-level safety, and elegant design, the Model S received endless praise. In some countries, it even became the first electric car to rank number 1 in monthly sales. That was the moment consumer perception and the market mood started to shift. Tesla did not stop there. In 2015, the company launched the Model X SUV, and in 2017, it introduced the Model 3, a more affordable sedan. The Model 3, in particular, brought electric vehicles much closer to the mainstream and became one of the best-selling electric cars in the world. In 2014, Tesla announced Autopilot, its driver assistance system. Musk set a goal of achieving full self-driving and repeatedly announced ambitious timelines. However, technical barriers and regulatory scrutiny still remained major challenges. Of course, Tesla's growth was not always smooth. The company had to deal with production problems, legal disputes, and massive financial pressure. On top of that, Musk's leadership style and public comments often sparked controversy and attracted attention from regulators. But Tesla's influence was not limited to cars. The company also focused on renewable energy solutions like solar panels and energy storage systems, aligning itself with the global sustainability movement. Tesla's success forced traditional automakers to speed up their own electric vehicle development, making the electric vehicle market more competitive than ever. While the auto industry raced toward electrification, expectations for electric vehicles ran into one major barrier: battery production. The promise that electric cars can reduce emissions is clearly attractive, but the process of making batteries comes with complex environmental and logistical problems. To produce lithium-ion batteries, the heart of electric vehicles, companies have to mine essential minerals like lithium, cobalt, and nickel. This process not only consumes massive amounts of resources, but also damages the environment. For example, in the region known as the Lithium Triangle in South America, which includes Chile, Bolivia, and Argentina, lithium mining has made water shortages more serious, causing major harm to ecosystems and local communities. Similarly, cobalt mining in the Democratic Republic of the Congo not only pollutes soil and water sources, but is also tied to human rights issues. But mineral mining is not the only problem. Battery manufacturing itself also requires huge amounts of energy, which produces a lot of greenhouse gases. According to some studies, producing one battery pack for an electric vehicle can create up to several tons of carbon dioxide emissions. That means the vehicle has to be used for a long enough time to offset the emissions created during the production process. On top of that, raw materials have to be transported across global supply chains, which increases the carbon footprint even more. And the problems do not stop there. As electric vehicle demand rises quickly, demand for key minerals like lithium, cobalt, and nickel is expected to far exceed supply. This could lead to resource shortages and sharp price increases. Even worse, these minerals are concentrated in politically unstable regions, making the situation even more complicated. For example, more than 60% of the world's cobalt supply comes from the Democratic Republic of the Congo, a country often surrounded by instability and ethical controversy. Reducing the environmental impact of batteries does not end with production. Managing batteries after they reach the end of their life is also a major issue. Today, the recycling rate for lithium-ion batteries is still very low, around 5%, because of major technical and economic barriers. If they are not handled properly, batteries can pollute soil and water. But if recycling is done effectively, environmental damage can be reduced and rare resources can be recovered. Companies like Nissan and Volkswagen have invested in battery recycling projects, but the scale is still not wide enough. In addition, shifting to electric vehicles requires huge investments in charging infrastructure, while the current power grid also has to carry much more pressure. In many regions, the infrastructure still cannot handle the growing demand for electric vehicles. If the electricity used to charge cars still comes from fossil fuels, the emissions benefits of electric vehicles can be greatly reduced. That is why whether electric cars truly reduce carbon depends closely on the decarbonization of the energy industry itself. Recognizing this reality, Toyota chose a more cautious approach instead of going all in on electric vehicles. The company continues to focus heavily on hybrid technology while also investing in alternatives like hydrogen fuel cells. This strategy reflects the belief that, in the short and medium term, multiple solutions, such as hybrids and hydrogen vehicles, may be more realistic and more environmentally responsible. In other words, Toyota is trying to find a balance between consumer demand, environmental impact, and resource limitations. Toyota has always led automotive technology by combining creativity, environmental responsibility, and excellent performance. With its strong engineering legacy, Toyota is now leading a new generation of internal combustion engines, challenging the trend of focusing only on electric cars and resetting the standard for the auto industry. In 2024, Toyota, together with Subaru and Mazda, announced a plan to develop advanced internal combustion engines. These engines are designed to work perfectly with hybrid systems and can run on carbon-neutral fuels. More importantly, they are much smaller than traditional engines, allowing vehicle bodies to be designed lower, improving aerodynamics and increasing fuel efficiency. Toyota's latest engine innovations focus on achieving optimal thermal efficiency while maintaining fuel flexibility. These engines are designed to run on gasoline, synthetic e-fuels, biodiesel, and even hydrogen. This versatility helps reduce dependence on fossil fuels while also supporting global efforts to cut carbon emissions. One notable technical advancement is shortening the piston stroke to make the engine more compact. This was a major challenge, but the result was an engine that is about 10 to 20% smaller than current models. When engine size is reduced, the front of the vehicle can be designed lower, airflow can be optimized more effectively, and fuel economy can improve. The torque loss caused by the shorter piston stroke is made up for by an electric motor, which provides instant power and keeps performance at an optimal level. The most groundbreaking part is how Toyota uses hydrogen fuel. Unlike traditional fuel cell vehicles, which convert hydrogen into electricity to power the vehicle, Toyota chose to burn hydrogen directly inside the engine. This approach makes the most of existing internal combustion engine technology while offering an environmentally friendly solution with almost zero carbon emissions and water vapor as the main byproduct. Toyota has tested hydrogen engines in motorsports, helping speed up the development of this technology. Data collected under extreme racing conditions helped Toyota fine-tune the technology more precisely and shorten the path toward using it in commercial vehicles. In 2024, Toyota once again joined hands with Subaru and Mazda in a joint project to develop new engines. The goal is to create engines optimized for hybrids and compatible with carbon-neutral fuels. The combination of each company's expertise and healthy competitive spirit has created a strategic partnership aimed at developing better powertrains. Looking ahead, Toyota plans to start introducing these advanced engines into vehicles from 2027. Especially in hybrid models, the internal combustion engine and electric motor will work side by side to deliver the best efficiency and performance. The high-efficiency, multi-fuel internal combustion engines Toyota is developing directly challenge the idea that electric vehicles are the only answer. By running on carbon-neutral fuels while still delivering strong performance, these engines not only give consumers more choices, but also become an attractive solution to the weaknesses of electric vehicles, such as the environmental impact of battery production and the limits of charging infrastructure. By 2023, the auto industry began to reveal the limits of a future focused heavily on electric vehicles. In many major markets, electric vehicle sales started slowing down, while charging infrastructure failed to keep up with growing demand. At the same time, pressure on power grids and energy costs became increasingly obvious. Even though electric vehicles had grown quickly, consumers began hesitating because of high prices, limited driving range, and a lack of charging stations, especially in rural areas. In the United States alone, from January to October of 2023, the electric vehicle market share reached only about 18%, falling short of the 22% target. The expansion of electric vehicles also added more pressure to national power grids. Many regions still lack the infrastructure needed to support large-scale charging, leading to long wait times and the risk of grid instability. On top of that, prices for key battery materials like lithium, cobalt, and nickel have become highly volatile because of supply chain disruptions and geopolitical tensions. Environmental problems caused by resource extraction and used battery disposal also raise questions about the long-term sustainability of electric vehicles. In this situation, traditional manufacturers began adjusting their strategies. For example, Ford realized that hybrid vehicles could play a bigger role than expected and started strengthening their position as a transitional solution. As the entire industry runs into difficulties, Toyota's cautious approach is becoming more convincing. Instead of putting all its resources into electric vehicles, Toyota continues investing in hybrids, hydrogen fuel cells, and other alternative technologies while offering a wider vehicle lineup to match consumer needs and infrastructure conditions in different regions. By maintaining a multi-direction strategy, Toyota avoids the risk of depending too heavily on one single technology while still supporting global efforts to reduce carbon emissions. So, can the internal combustion engine really make a comeback and become a true rival to electric vehicles? Or is this just the final struggle of a traditional giant trying to hold on? The answer is still open. But one thing is certain, the technology race is not over. It has only entered a completely new phase. Thank you for watching until the end of the video, and we have one more important piece of news to share. Our channel is getting very close to the milestone of 55,000 subscribers. This is only possible because of your incredible support. One subscription is not just a number. It is the motivation that helps us keep creating better technology content. If this video was helpful, make sure to hit the like button, subscribe to the channel, and turn on notifications so you do not miss the exciting videos coming next.